Hello, everybody, and welcome to the Reuse Company webinars. My name is Cecilia, and I will be hosting today's webinar. With me today, I have Eugenio Parra, Artificial Intelligence Architect at the University Carlos III in Madrid. You will be muted during the webinar, but if you have any questions or comments, you can use the chat box. But please address your comments to the Reuse Company and not to the presenter. If you have any technical issues, please use the chat box or send an email to support@reusecompany.com. The webinar will be recorded, and in a few days we will send you the link to the recording. First, we will have a short presentation of the Reuse Company. Then we will listen to Eugenio, and after that we will have some time for questions. Okay, let's start with a few words about the Reuse Company. We are a worldwide company. We have partners in France, Germany, Italy, Spain, and Japan, and customers in the US, Europe, and Asia. Our headquarters is in Madrid, but we also have offices in Stockholm and in London. Here you can also see some companies that are users of our system. They are from aerospace industry, defense, automotive, railway, and energy, among others. We provide tools and solutions for knowledge, traceability, reuse, and quality management. We do that by using semantic analysis technologies, and these technologies are used in a wide range of industries. We haven't yet found any industry that couldn't make use of our tools. Our focus is on use, traceability, and quality, and we integrate the tools and the technology we have with the way that you do your work. We provide the data that allow you to present your quality analysis. We allow you to develop your knowledge bases so that you can most accurately assess the quality of your specifications. Our mission is to reuse knowledge within any organization. Knowledge is probably the most valuable asset of any company, and we can offer processes, methods, tools. Our technologies are innovative, artificial intelligence-based, and we are having a lot of success helping people improve the quality of their documentation. Now let me introduce you to the presenter. Eugenio Parra is a visiting professor at the University Carlos III in Madrid, Spain. He is a quality metrics architect and an artificial intelligence architect, and he's collaborating a lot with the Reuse Company. His research includes studying new approaches for quality analysis based on artificial intelligence techniques in combination with semantic approaches for requirements engineering, natural language processing, and artificial intelligence. Eugenio has published some papers on topics such as reuse of knowledge and improvement of the quality of requirements. He also participates as a researcher in different European projects. So let's listen to Eugenio talking about applying machine learning techniques to the flexible assessment of requirements quality.
Okay. Hello, thanks Cecilia, everybody. Okay, in this slide you can see that requirement engineering is a discipline aimed at semantic development of needs research and to present these needs in the best possible way. Requirement engineering is part of system engineering, so they serve as a basis of the generation of an increasingly complex system. The success of a project is strongly linked to the requirements. That is why it is necessary high-quality requirements. The quality of requirements affect the project, but we have seen that also the project demands different quality restrictions. For this, a methodology is presented to optimize the quality of requirements adapting to the specific project needs. This methodology takes into account to a requirements corpus. These requirements must be classified according to their quality by an expert, and we use automatic processing in order to learn the quality provided by the user. In the next slide, I'm going to explain this deeply. Okay, what is the objective of the methodology? The objectives are emulate the quality classification that would be provided by an expert and domain expert on the requirements, and to optimize the quality of the requirements through automatic correction suggestions. This slide I want to represent that different organizations like INCOSI, ISO, and so on have developed guides and standards to improve the quality of the requirement specifications. These guidelines and standards define the several properties that the requirement must comply. For instance, precision, completeness, consistency, ambiguity, verifiability, and stability, and others. In the paper references in this slide, the authors, Genova, the authors and other authors, they propose a set of quality metrics to measure these desirable properties with quantitative indicators. That means the authors provide a quantitative value for the measurement of these properties. These quality metrics, for instance, we can use a number of connectors, number of design expression, number of passive verbs, number of words. You see, it's necessary to extract quality metric for requirements in order to measure with a quantitative indicator the quality of these desirable property. In this methodology, we are using the LQA. LQA provides a set of metrics in order to measure this quality. Like, for example, number of paragraphs, number of words, number of indefinite articles, imperative mode, and so on. So in this case, all of these metrics is included in the methodology out of the box. So it's possible to use it without a complete methodology. Okay. This methodology contains different steps. In this case, the methodology contains, I want to say that the methodology contains a process, and the process contains tasks. So the process of this methodology are classifier generation and quality estimation of the new requirements. For the classifier generation, we have these different tasks: create a corpus of classified requirements, extract quality metric for each requirement, generate learning instances with this value of the quality metric, and generate the classifier. This by the processing of these learning instances. And the tasks of the quality estimation, of the requirement, extract metrics from the new requirement, generate evaluation instances, and this evaluation instances is processed by the classifier in order to estimate the quality of the new requirement. All of these steps I'm going to explain deeply in the next slide. So this is the classifier generation process. As I told you, we have a corpus of classifier requirements. It's necessary that in order to use this methodology or this process, it's necessary that an expert, an expert of the domain, or expert of the requirement, expert of the project, classify the quality of each requirement. I have to say that these requirements are written in natural language. So in this case, it's possible to classify by good quality and bad quality. So with this set of requirements, it's possible to extract the quality metric. In this case, we use the RQA. RQA process each requirement and extract a set of metric, a set of value that represent these requirements, okay, with quantitative indicators. With this value, after this process, we have a quantitative indicator for each requirement. Okay, so with these values, with this quality metric, we create learning instances, and the learning instances is that the values of the quality metric for each requirement and the quality of requirement provided by an expert. Okay, so this is the representation of the quality of the requirements and the quality value. With these learning instances, it's possible to use the machine learning algorithm in order to know which is the combination between the metrics in order to learn the quality, the combination of the metrics according to the quality of the requirements. So the result of this machine learning algorithm is a classifier. This classifier contains all the knowledge that the user tries to transmit with the classification requirements. Imagine that you have now the quality, the classifier. You have a classifier, but now I want to know the quality of the new requirements. So in this process, we have a corpus with the new requirements, and I want to know the quality of these requirements. This we have to use RQA in order to extract the same quality metrics that we are extracted in the classifier generation process. With these values of the quality metrics, it's possible to create evaluation instances. This evaluation instances is the quality metrics, okay? But we don't have the quality value, because the quality value is the quality that you want to learn, that you want to know. So with these evaluation instances is processed by the classifier, and according to the classifier generated, the result are the quality of this new requirement. Okay, let me introduce an example how to estimate the quality of the new requirement. Imagine that we learn and we obtain a classifier by the processing of the set of corpus provided by the expert. Okay, and we have a classifier. In this case, is generated with the algorithm C4.5. Generate a classifier in a three-way. Okay, now we want to know the quality of this new requirement. In this case, we have these two requirements where the systems are sent, the systems are half, and so on. And I want to show you what is the different words that provide different values in the metric that we are going to use in this example. And this is this, for example. Second requirement, we have a good, we have in order to, we have a height, and this is this by the processing of this requirement, the quality matrix gives a value, for example, to the words or set of combination of words in order to. In order to, there are a metric in RQA that say that it's not possible to use rational sentence, or this is if you use rational sentence, maybe you have a bad quality requirement. So the metric evaluate these words and decide and provide a value for these quality metrics. So extracting and processing, RQA process this requirement, and this is the set of quality metrics that provide for this requirement. We only use these metrics for this example. For example, number of paragraphs. In this case, we have only one paragraph for each requirement. That is good. Okay. The number of words, but for example, the number of rational sentences in the requirement 1, 0, and the requirement 2, you can see that we have 1. 1 is the number of rational sentences that the LQA finds in the process. Okay, characteristic math, subjective expression, and definite articles, and so on. So, with this value of the requirements, this value of the requirements is processed by the classifier. And in the first requirement, these rules are triggered. In this case, we have are triggered the number of paragraphs less or equal than 4, number of words less or equal than 50, and so on. So with this rule included in the classifier, we have a quality value. In this case, the classifier say that we have for this requirement 1 and for this combination of the quality metrics, we obtain good quality. But in the second requirement, when the classifier process this requirement, these rules are triggered. In this case, you have the number of the indefinite articles is greater or equal than 2, and the number of suggested expression is greater than 0, and you use AND conjunction. So with this rule are triggered, and then the result of this rule is that this requirement has bad quality. You have to think that these rules is learned in the classifier generation process. So it's not established by the user. It's not established by the user that use this methodology. Is learned by the corpus provided by the expert domain. Okay? So, in order to prove the validation of this methodology, we created an experiment, and we used a requirement corpus that contains 1055 classified requirements, and this corpus was provided by the INCOSER, the Requirements Engineering Group, or if INCOSER. And we have that the expert of the requirements in this group, in this organization, evaluate that the requirements and provide 545 requirements with quality, and for 490 requirements with bad quality. In order to check different algorithms, we use these six algorithms. So, and I want to say that this algorithm create classifier with in a rule way. So the classifier is the component of the classifier is a set of rules. Okay, in order that means, for example, if this metric is greater or equal than the value, and a tree way. Okay, the tree way is like a tree, and if you follow the different values, you obtain the classification. Okay? In this case, the classification of the quality. Okay, the results of the experimentation, in this case the accuracy, is in all of the cases is greater than 80%. So the best was bad in part, but it's not. So we don't have a lot of differences between okay. All of this research, all of this study, and the experimentation and the presentation of methodology is published in the paper that you can see in this slide. And I want to say that in order to know the value, in order to know the value of the validation, in order to validate this experimentation, we use the cross-validation process. This cross-validation process learn with the 90% with the 90% of the requirements, we create the classifier, and the other 10% of the requirement is used to evaluate the result. Okay, and it's a complex process, but this is the idea that you have to evaluate the requirements, but you don't learn this requirement in the classifier generation. Okay. So we have another objective in this methodology, that was improving the quality of the requirement. Imagine that you want to process the requirement, and you and the classifier say that you have bad quality. Okay, but what I have to do in order to improve the quality of my requirement? So it's possible. We create a module that learn and study the different rules of the classifier, and then it's possible to know why this requirement has a bad quality. Imagine that you introduce a requirement, and the classifier say that you have bad quality, and this is the different rules that provide this quality, or that match with the value of the quality metric. In this case, for example, you have number of indefinite articles, number of text expression, and number of verbs in passive voice. Okay, so the idea is we want to change the quality of the value, the quality value of the requirement, with the less change possible. Okay, in this case, we have these three rules, and it's easier to change or to modify the value, to modify the requirement. For example, if you delete the undefined article, is easier to have this to change this quality metrics, or that you, for example, try to use the last one, number of words less than 7, and it's necessary to include more words. So the idea is that the suggestion model say you the less change possible in order to improve this quality metric. And this is because it's possible to learn and to study the value, the rules that compose the classifier. Okay, this is the conclusions. Our methods have been processed to assess the quality of requirements in a flexible way using machine learning techniques. And I want to explain why it's flexible. And this is one of the words in the title of the webinar. Okay, it's flexible because the quality restriction in this methodology is provided by the quality judgment of the expert to the requirements. Okay, if you have a more restricted and more complex project, you have to evaluate the user have to evaluate the requirements in order to represent this complexity in the requirements. Okay, so this is the idea of this methodology, that it's not the user or the author of the methodology don't provide a set of restrictions, a set of or a range of the quality value. This quality value is learning by the classification of the requirement of the requirement provided by the user. So it's the user that provides the restriction of the quality for each requirement. Okay, the method was evaluated in experiment using a set of requirements provided by inclusive organization. And all of this, as I told you, all of this is published in a paper to explain all of this deeply. Okay? And a suggestion model was created based on the classifier, okay, in order to improve the quality to the requirement, and this improvement is flexible or is adapted to the restriction of the user, okay, of the expert domain. Okay? So how we can improve this process. The method that I presented in this presentation is all related to correctness method. Why? Because this is the method that is possible to obtain the value only with an empty ontology. But it's possible to add new metric based on complete ontology. And of course, if you include more metrics, and that means that if you include more knowledge in the process, you will obtain better results. For this, the research company provides, as you know, knowledge manager tool. It's a tool that is possible to create and to store the different terms, and not only this, it's possible to create semantic and syntactic relationship between the terms. It's possible to create hierarchical views of the terminology and the verbs, and it's possible to use do a lot of things. Okay, so with this and using this knowledge manager, this knowledge tool, it's possible to create a complete ontology, and with this, there are metrics in RQA that use all of this information in order to give values. Okay? Give value to measure, to take a quantitative measure, for example, for the semantic of your requirement. If you add all of this information in this methodology, you obtain, in this case, a semantic quality value for each requirement. So, not only for correct metric, it's possible to use this for more more areas of the knowledge. Okay? This is the way to improve, and this is a very good experiment possible to do. Okay?
Okay, thank you very much, Eugenio. If you have any comments or questions about Eugenio's presentation, you can send them through the chat box to the reuse company. I will give you a couple of minutes to write down your questions, and meanwhile I'll tell you about our next webinar. It's called A Practical Way to Implement ISO 15288 VNV Processes, the VNV Studio. The verification and validation processes of the ISO 15288 describe in a general way how to perform VNV for a complex system. However, the standard also suggests the need to apply VNV not only to the right side of the V model, but also to the requirements, architecture, and design processes outcomes along the left side of the V model. The dates for this webinar will be October 22nd and 24th. I also would like to promote another event where we are collaborating. It's called Artificial Intelligence for Systems Engineering Workshop, and it's the first workshop on the application of artificial intelligence for system engineering. This is an in-COSA event, and the dates are November 12th and 13th. You can find more information on this website. Okay, so let's see if we have any questions. Yes, is it planned to introduce these new techniques into RQA?
Okay. Okay. Not now. Not now. Okay. There is no. This methodology is not included in the RQA, but there are. It's possible that in the next RQA versions, it's possible to introduce this new functionality. Not only this, the functionality related with artificial intelligence, like for example, new quality metrics with using artificial intelligence, and to use for example, automatic generation of methodology and so on. So not now, but we are working on this new area in order to improve all the tools provided by the previous company.
Thank you. Would it be possible to use deep neural networks to create a classification module?
Okay. Yes, that is possible to use to create classifier. Okay, the classification models using neural network. There are a lot of research related to create classification, and it's possible to obtain very good results. But there are problems here that the neural network works like a black box, that the author says. And that means that it's not possible to know why is the result of the neural network. Okay, imagine that you introduce a requirement and the neural network say, okay, you have a bad quality, but it's not possible to know why is the different parameters that this neural network uses to provide this result. As I showed you in the slide, one of the objectives was to create a suggestion model. So this suggestion model is used or is created by the processing of the anti-learning study, the composition of the classifier. Okay? So it's not possible to create a suggestion model if you use a neural network. But if you want to only obtain the result, it's possible to use, of course, the neural our objective was to say not only what is the quality of the requirement, but to say how, what is the different thing that you have to do in the requirement in order to improve the quality.
Okay, thank you. Did this methodology work only for requirements, or is it possible to use it for other products as well?
No, of course. This methodology, the experimentation of this methodology was focused in the requirements. Okay, but as you know, LQA provide the processing of different work products, like for example, models. Okay, and now the possibility for the create is amazing because it's possible to create and make a connection for a lot of different tools and to extract the different the metrics for different for a lot of different work products. So if you use this and you extract the quality metrics for every work product, after this process, it's possible to use this methodology and create the learning instances and generate classifier. And if you do the same with the new work product, it's possible to start quality metrics and so on. So it's possible to use this methodology, and we prove that with experimentation that it's possible to use, and we obtain good results. That is possible to if you use and you extract quality metric for all work products, it's possible to use this methodology.
Thank you. In the experiment, you use only correction metrics. Could you include metrics to measure the consistency and completeness properties?
Okay. In this case, in the experimentation, we only use the correctness metric. As I told you, is because it's possible to use this with an empty ontology, or with the ontology out of the box that provide the base company. But similar that the correctness the correctness metric that use ontology in order to measure the correctness related to the semantic relationship, it's possible, of course, to create a ontology in order to use the different completeness and consistency metrics that the equate provide. I think that there are equate provide the 10, I think it's 10 quality metrics for completeness and consistency, but there are possibilities to create a custom code, so it's possible to integrate a lot of consistency and completeness metrics. So if you have the knowledge in your ontology, it's possible to extract the value for completeness and consistency, and of course, it's possible to add and include these values to the process, and with this, we provide more knowledge to the process, more knowledge to the classifier, and the result of the classifier or the classification of the new requirements will be improved, of course. So the answer is that yes, it's possible to use a completeness and consistency metric, but it's necessary to have to count a good or complete ontology.
Okay, thank you very much, Eugenio. You will receive the presentation and the video in a couple of days. And if you have any further questions or want to have more information, don't hesitate to contact us by email to contact@reusecompany.com or through our website, reusecompany.com. Thank you for your attention, and see you on our next webinar.
Thank you. Everyone.
Goodbye.
Bye.